we already covered 2-tier and 3-tier designs. Now, as we start going through and we start looking at the last configuration has a couple of names. One of them is a leaf spine architecture. The other is, you'll hear a lot of people use the word CLOS, C-L-O-S design. Now, that's not an abbreviation. It's actually a man's name. Charles Closs was a research engineer in the 1950s who created a non-head of line blocking crossbar fabric. Now, basically, it translates to this idea of a leaf spine architecture. So it should come as no surprise that we're talking about a design that has 2 layers. So if I were to draw a leaf spine design, this is what we're talking about. So these would be my spines. These would be my leaves. Now, when it comes to leaf spine design was optimized to support the concept of east-west traffic. And it was also implemented and designed to give me some control and some ability to be able to fix the latency in my network. And we do that by controlling how far information or how far packets actually travel. So if we were to look at this like the real world, now this is not an ACI infrastructure. This is a CLOS design, leaf spine design. And we would have exactly what we had before, where we would have connectivity to our service provider. Well, I always just call the ISP, the Internet Service Provider. And we know that these would be layer 3 connections. Then what I have to do is I have to connect my leaves to my spines. And the way that this happens is that every leaf is connected to every spine. Okay, and you should automatically see the first drawback to this design. Cabling gets very, very complex. However, as leaf 1, leaf 2, leaf 3, leaf 4, leaf 5, and leaf 6 are going to be connected to spine 1 and spine 2, the thing that we have to note is the fact that at this particular instance, we have a point of demarcation like we had before. But oddly enough, a lot of people think that it's here, but it's not. The point of demarcation that we have is from the spine switches or the leaf switches down. So my layer 2 infrastructure resides here where I have my hosts. So the goal here is that I want to have this idea of fixed latency, and since this is what we refer to also as a massively scalable data center design, what I want to do is I want to be able to support a lot of traffic coming from virtual devices, virtual routers, virtual switches, virtual hosts, virtual servers. But, like I said, in this scenario, there are some things that we want to make certain that we note. So one of the things that makes this different than, say, for instance, like a 2-tier design is this point of demarcation, because we are layer 3 all the way from the leaves up to the service provider. Now what that means is inside of here, since I'm using a routing protocol or layer 3 functionality, I get the capability of being able to support equal cost multipathing in this infrastructure. But let's operate under the assumption that I have a virtual machine running here. And I want to use something like vMotion to move that virtual machine over here. Well, the problem here is that my layer 2 infrastructure may change, or I may not want it to. So this guy may be in VLAN 100 here, and when I move him over here, so I'm going to take him out of here and I'm going to put this virtual machine over here, I need him to be in the same VLAN. In other words, I want him to have the same IP address. I want to have interconnectivity in place to where I can support moving him over, but he does not drop out of the network that he's currently connected in. So when we look at this, we get the benefit of equal cost multipathing, routing protocols, everything at layer 3. If I need more throughput, I could always add more spines. If I need to handle more users, I can always add more leaves. But the problem is that we have this scenario that we just described that requires that I need to find a way to extend the layer 2 environment. So I want to maintain layer 2 adjacency between different leaf switches. Now, the problem with that is that we have to utilize a tool to do that. For the most part, we will employ something called an overlay VPN. So what we're going to basically do in this scenario is if I want to maintain layer 2 connectivity, I have to create a layer 2 tunnel that's going to run between the leaves on top of the layer 3 infrastructure. The overlay is what we call this tunnel, and it runs on top of the layer 3 infrastructure, which we have a habit of calling the underlay. Technologies that support this, probably the most common are going to be solutions in this scenario would be a virtual extensible local area network, which we're going to be studying in the DCICT portion of this course. But don't get this design confused with a 2-tier design. The 2-tier design collapses the aggregation in the core layer into a single layer, but we still have the point of demarcation between layer 2 and layer 3 in that collapsed area. Inside of a CLOS design, the layer 3, layer 2 point of demarcation exists at the lowest point of my total fabric. So all of these switches acting together in this CLOS design, in this leaf spine design, provide those services. Like I said, it can get relatively complicated. It can get complicated into the number, the type, and the mechanism used to manage and build overlays. It can also get very complicated in the way that we cable things. It can also even get even more complicated if we start looking at things like extending to different locations via solutions like dark fiber. But all of that will come later on in your studies. I'm not trying to scare you. I just want you to understand that this is the way things are happening today in most Scratch builds. And it's definitely worthwhile to make sure that you understand the difference between a 2-tier, a 3-tier, and a spine leaf architecture, not just for the exam, although I know they're going to ask you questions about it, but for the real world as well. All right, with that, I hope this was helpful. I'll see you guys in the next lesson. Till then, I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.